Hi there, welcome back to this channel. In this short video, I'm going to be showing you quantum numbers, how to calculate quantum numbers. Now, or how to find them. Now listen, the first thing you have to know is why we need them. Why do we need quantum numbers? Now, quantum numbers are numbers that designate the exact position or that can predict the position of a particular electron, exactly in an atom. Alright, so first, we now know that the structure of an atom looks like this. There is a central nucleus where we have the proton and neutron, and surrounding it are orbits or electrons orbiting. Um, um, and that path that they take is called the orbital, right? So we define an orbital as the region in space around a nucleus where the probability of finding an electron is maximum. Okay, it's just big English. What I'm saying is, if you know your father, for example, very well, you probably know the spots where you can find him. If you get to and you don't meet him at home, you can guess where he is. So those places where you can find him are like his orbitals. Take it like the orbitals. So they are um, the places where the probability of finding him is maximum. Exactly. All right. So and there are four quantum numbers that we are going to be discussing today. Four quantum numbers. Now, the first one is this. The first one is the principal quantum number. Number one, principal quantum number. Now, the principal quantum number takes the letter N. The principal quantum number basically tells us the energy level of the electron, the energy level in which we can find the electron. Remember, we're using quantum number to find electrons. So the energy level of the electron. So for our 118 elements, there are basically 7 energy levels. 7 energy levels. So of those 7 energy levels, we call them shells. We call them KLMNOPQ shells. Exactly. The first shell K has energy level 1. It's called energy level 1 rather. Exactly. Now the second quantum number you want to learn is the azimuthal. The azimuthal quantum number. The azimuthal quantum number is also called the angular momentum quantum number, the angular momentum quantum number, or the subsidiary quantum number. And it is designated, L. Okay, it's designated small letter L. And it is the one that tells us the orbital in which we can find the electron. This one tells us the energy. This one tells us the particular orbital. Now, why do we need this? Remember that according to Hofbauer, the electrons are filled in by building up, right? Okay, so if they build up, it's such that the first energy level is going to have just one orbital. Second energy level will have S and P orbital. Third energy level will have S, P, and D. Just remember Power Rangers SPD. You're going to be able to remember the the orbitals. So there are 4 orbitals they are basically looking at. They have the S, P, D, F. Okay, this is the sharp orbital principle, the diffuse and fused. Now the S orbital is designated azimuthal quantum number 0. P takes azimuthal quantum number 1, D takes 2, this takes F takes 3. Remember that the p orbital is degenerate, right? The p orbital is degenerate. So if the p orbital is degenerate into 3, it's degenerate into px, py, and pz. The d orbital is degenerate into 5. That's why, and so for this p, the maximum number of electrons I can enter for this s maximum is 2. This one is 6. Why? Because it's degenerate into 3, meaning that 2 will enter each of the orbital. D is degenerate into 10, has 10 as the maximum number of electrons that can enter, meaning it's degenerate into 5. Then for the F, we have 14. F for 14, just remember that way. Or 10, 10, 10 is the difference. So this one will be degenerate into how many? 7. Exactly now. Good. So now the azimuthal quantum number L can take values from 0 to n minus 1. Azimuthal quantum number takes value from what? 0 to n minus 1. Then, so it means that if n is 3, for example, Then azimuthal quantum number, for example, if n is 3, azimuthal quantum number will take the range of values 0, 1, 2. Now, this 0, 1, 2 corresponds to which orbitals? S, P, D, meaning that no f orbital in this energy level. And of course, we said it's 3. N is 3, right? It means it's in energy level 3. And if you remember what I drew for you, 1s, 2s, 2p, 3s, 3p, 3d, you see that now that there are 3 orbitals inside the third energy level. Then the third one is the magnetic quantum number. Now the magnetic quantum number is given m sub l, is designated m sub l. Now what does this one tells us? This one tells us the specific orbital in a degenerate orbital. The specific orbital in a degenerate orbital. So for example, if we find our L, okay, first, the m sub l takes value from minus L to plus L. So for this our example, if the question was 3D, maybe 3D2, to find the 3D2 on the electron, that is the second electron in the d orbital of the third energy level. I repeat myself, the second electron in the d orbital of the third energy level. That's what you have to find. Your n will be 3, meaning that L will take value 0, 1, 2, and since 3 is D, I mean, this is D here, it means our L will be 2, because 2 is the number that corresponds to the d orbital. So it means that our m sub l will be from negative of that value 2, that will be minus 2, minus 1, 0, 1, 2. Now what does this prove? This proves that how many orbitals is D degenerating to? D is degenerating to 5. You know, I told you it's 10 maximum. So 2 to 2 in 5 places. So let's check it out. 1, 2, 3, 4, 5. These are the 5 orbitals. So I'll link the video where I discuss their concepts in full. Okay, I gave you the formulas for each of these specific orbitals within the D. So now when you want to feel it here, you feel 1 and 2. This is the second orbital. Now the third one, the fourth quantum number, is now the spin quantum number. Spin quantum number is actually called the magnetic spin. So we call it m sub s. Exactly. This one m sub l. This one m sub s. Now the m sub s takes only 2 values. When it is an upward spin, you should upward spin give it plus half. Plus half. For example, this one is an upward spin, so it will take plus 1. If it's a downward spin, give it negative half. I repeat myself. Let's find this 3D2 orbital now. 3D2 electron now. What will be the set of quantum number for a 3D2 electron? The n for that electron, where we find it, the energy level is energy level 3. That's what you can see here. This number designates the energy, represents the energy level. Then, if n is 3, L will take 0, 1, 2. That is, it will go from 0 to n minus 1. And that is 2 here, right? So, now, looking at this, this is D. D corresponds to which of the number here? O is 0 is PS, 1 is P, 2 is D. So, our answer will be D. So, L is equal to 2. Okay, L is equal to 2. Now, what will M sub L be? M sub L is going to take negative of L to positive of L. We have minus 2, minus 1, 0, 1, 2. Like what I did here. And I filled it in. So you have to now fill it, you have to fill in the 2 electrons. So the first one will be 1, 2. Now the rule I followed here, why did I not feel like this? 1, 2. Is because of Hund's rule of maximum multiplicity. Hund's rule. So Hund's rule says that you have to fill electrons into orbital singly first before pairing them. So you have to go 1, 2. Okay? So now 1, 2. If I do it like this, 1 and I do 2 here, I have flouted Hund's rule. Is that clear? So that's the case there. I stopped at minus 2. So M sub L, I stopped at minus 1. Minus 1. So M sub L will be minus 1. Where we stop. So for example, if it was 7, D7, 3D7, I'm looking for the 7th electron in the d orbital of the third energy level. I'll just fill 1, 1, 2, 3, 4, 5, 6, 7. Okay, M sub L will still be minus 1 because the seventh one still ended here. It was 6. It will end here. Is that clear? So that will be minus 2 for 3d6. Is that clear? Now let's go on. Like I said, for this one, M sub L is minus 1 because it stopped here. Then M sub S, let's check the spin. Is it spinning up or down? This last electron here is spinning up. That will be plus half. Is that clear? Now let me solve one more. Question. What if we are asked to find the four quantum numbers? The four quantum numbers for the 4p5 electron. 4p5 electron. 4p5. So how do we check? We know that N will be the energy level. What's the energy level? We can see here, fourth energy level. So N is 4. If N takes 4, then L will take value 0, 1, 2, 3. These are the possible values for L. And 0 corresponds to S, 1 corresponds to P, 2 corresponds to D, 3 corresponds to F. Now, what can you see here? What you are seeing is P. So it means that our L is 1. Is that clear? L is 1. So M sub L then takes value, the possible values are from minus of L to positive L. So these are the possible values. See, I'm drawing them out to show you Px, Py, and Pz. Is that correct? This is minus 1, 0, and 1. Now, I have to fill in the 5 electrons to see where the 5th electron lands. So I have 1, 2, 3, 4, 5. The 5th electron lands where? At the 0. So M sub L equals 0. Is that clear? Then M sub S. Now, what's the spin of that 5th electron? It's negative. It's downward spin rather. So it'll be negative half. Is that clear? Do not subscribe to the channel. If you don't understand, see the video or link in the description for full conceptual overview. God bless you as you subscribe and share the video with your friend.